Alright, example 4, very similar, limits with just a little more complex of a formula. What we're going to do is, again, we're plugging this into our formula. The limit of h approaches 0. We're finding the rate of change at the point 26. So our limit of h as it approaches 0 is f at a plus h minus f at a divided by h. Okay. This time we're just going to go right into it. So, limit of h at 0. Okay, we have this formula here. Our a value is 2. Our f at a value is 6. They've already given that to us, so there's nothing really to solve there. What we're going to do is now plug this into the function of a plus h. So we get 3 times 2 plus 6. Where are we? No, not plus 6. Plus h. Not 2. Yes, 2. Oh, I apologize. I've written this wrong. Here we go. Okay, our function of f at 2 plus h minus, this just becomes 6. So we have that all out there. We now plug it into the function. Okay. So what we're going to do is we're going to replace our x with 2 plus h. So 3 times 2 plus h plus 6 divided by our a value again, which is 2, subtract 6, all divided by h. Okay. And that there was when we plugged our formula in. We go to simplify this, so specifically the top part of the formula. When we go to simplify it, 3 times 2 gives us our 6 plus 3h plus 6, all divided by 2. Yes. Oh, I apologize. There were 2 x's in here. When we replaced them, we should have had a plus h, or in this case 2 plus h, replacing both of them. So the only mistake we made, or I made, sorry, is here. This should be 2 plus h at the bottom, just like this one was 2 plus h. Okay? So this is 2 plus h at the bottom, minus 6, all divided by our h term. Okay. So, what we're going to need to do here is we actually need to add, or in this case, subtract fractions. So I need to turn our number 6 into a fraction with the same denominator from below. Well, in order to do that, I'm going to multiply, because technically this is 6 over 1. The bottom of this fraction with 2 plus h, and the top of this fraction with 2 plus h. Okay? That way we can actually start to collect our like terms. We're still going to have a fraction on top. H approaches 0. This time, though, it's going to read 6 plus 6 is going to give us our 12. 12 plus 3h, subtract, and here we have negative 6 times 2 gives us negative 12 minus h. Minus 6h. Thank you. There you go. And it's all going to be over the same denominator, which is 2 plus h, and again, that's still over h. So it looks like we have a triple fraction going on here. We're going to collect our like terms at the top here and try to work through this. Our limit of h as it approaches 0. We have 12 and negative 12. So these are going to create a 0 or cancel out. 3h minus 6h is going to give us negative 3h divided by 2 plus h, again divided by h. Now, I'm going to rewrite this. So it looks like a fraction divided by a fraction, but more in a horizontal fashion. So negative 3h divided by 2 plus h divided by h. Okay? Now remember, when we're dividing fractions, we flip and multiply. So I get negative 3h divided by 2 plus h times 1 over h. That's not an h. Okay? This is technically h over 1. So when we go to combine that, limit of h as it approaches 0, we're going to get negative 3h over 2. Or in this case, actually, what we'll do is we'll write it as h times 2 plus h. And the reason we've written it this way is so that I can see that I can cancel out my h's here. Okay? I could have brought it in, but I would have had to factor out again to cancel out the h. So we have the limit of h as it approaches 0, negative 3 divided by 2 plus h. This is as simple as we get. So now again, we're going to substitute our 0 in for our h, and the limit is equivalent of negative 3 over 2 or negative 1.5. So the rate of change at that point is negative 1.5. So at the point 2 and 6, the rate of change at that function is negative 1.5 or negative 3 over 2.